Greetings to everyone. Hope you all are hale and hearty. And I'm Vijayasuta Priyadarshini Gaur, an undergraduate from MEM Engineering College, Jodhpur. And in this module, we're going to be discussing the solutions to sample paper number 4, targeting class 9th. So without any further ado, let's get started. So the first question of the module says, write the given statements in your answer books after filling in the blanks. A part says, Phyla and Unio have an external shell and belong to the phylum what? Then free-living marine animals with water-driven systems are in the phylum, fill in the blanks again, and to which phylum do sponges belong? So the answer to the first question, which is Phyla and Unio have an external shell and belong to the phylum of mollusks, as we all know. And then the free-living marine animals with water-driven tubes are known to be in the phylum of Echinodermatas. As you can see, this is your phylum Echinodermatas, and you have these all tubular creatures, these tubules. And then finally, to which phylum do sponges belong? Then sponges belong to the phylum of Porifera. And these are some creative representations of the examples of these classes, like the snail here, and these belongs to the phylum of mollusks. And then you have phylum Echinodermata, in which you have starfish and other fishes, creatures which have tubulars. And then you have phylum Porifera of sponges. Now the next question says, differentiate between monocots and dicots, and then give two differences and one example of each. Then monocots are nothing but one cartilaginous parallel venation fibrous roots. And the examples to monocots are wheat, maize, and rice. And dicots are two cotyledonous or reticulate venation or taproot or green grams. And so basically the example, these are green grams and peas. And also the basic difference can also be understood by looking at this image right here. You have monocots, they have one cotyledons, and then you have dicots, which have two cotyledons right here. And then when it comes to leaf venation, your monocots have veins which are usually parallel to each other. Whereas if you see your dicots, these veins are having a net-like structure. And then when it comes to stems, they have the monocots have vascular bundles which are usually complexly arranged. And then in the case of dicots, you have vascular bundles which are arranged in the ring pattern. Then you have roots. The monocots have very fibrous roots, as well as dicots. They have taproot. And finally, flowers. Fluoroplasts usually in multiple of 3, and here they have in multiples of 4 or multiples of 5. And the examples that we already discussed that are monocots are wheat, maize, and rice, and in dicots it's green gram and pea. And yes, you can easily remember the basic difference by looking at this diagram. Let's move on to the next question. States the law of constant proportion in the A part, and in the B part it says, in a compound, carbon and oxygen react in the ratio of 3:8 by mass to form carbon dioxide. What mass of oxygen is required to react completely with 9 grams of carbon? So firstly, in the first part that we're going to talk about, we're going to state what is the law of chemical proportion. Any chemical substance has always risen in definite proportions by mass. So basically, it can also be put as the law of definite proportions, which is stated by Proust. As in a chemical substance, the elements are always present in definite proportions by mass. And an example is also given right here, that in a formation of water compound, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of water is. Thus, if 9 grams of water is decomposed, 1 gram of hydrogen and 8 grams of oxygen is always contained. That simply, you can understand this simply by the fact that in any compound, in the formation of any chemical compound, its elements are going to be mixed in a very specific mass, in a very specific quantity, and only then it would generate the specific compound that we need. Any irregularity in that amount of mass would not give us the required compound. So be it any compound in the world, if it's composing like that of, in this case of hydrogen, we are dealing with hydrogen and oxygen, and they're combining with each other to form the molecules of water. So if they are going to combine with each other in a very specific manner, at the very specific mass ratio, only then the water is going to be formed. Else, if this ratio is going to change, the product that we will be obtaining will also change. So this was your mass of definite proportion, law of definite proportion by mass. And in the B part, the question says in a compound, carbon and oxygen react in the ratio of 3:8 by mass to form carbon dioxide. What mass of oxygen is required to repeatedly to react completely with 9 grams? So here I have divided B part into further C and D as well. And now how we are going to understand this is that C, it is given to us that 3 grams of carbon needs 8 grams of oxygen. So 1 gram of carbon shall need 8 by 3 grams of oxygen, and hence for 9 grams of carbon, this 8 by 3 for a unit into 9 gives you 24 grams. So therefore we need, for 9 grams of carbon, we need a total of 24 grams of oxygen. So the next question says again, calculate the mass of molecules which have been present in 4.4 grams of CO2 at mass C is equal to 12, O is equal to 16 atomic mass unit. And then you have the Avogadro number, that is 6.02 into 10 raised to the power 23. This is 23 right here, guys. Uh, this is supposedly to be written as 10 to the power 23. And these are the molecular weights of carbon and oxygen. And then finally, the B part, it says what are the polyatomic ions, and give one example. Okay, so the first part, calculate the number of molecules in Na2SO4. So the number of molecules shall thus be calculated as the number of moles into 6.02 into 10 to the power 23. This is again 10 to the power 23. That is, the number of moles shall now be equal to, on calculations, we'll give it to be 0.5. Now, how did it came out to be 0.5 can be understood by the fact that when you add up all the constituents of Na2SO4 and you divide that with the given 72, given amount 71, that is given mass divided by the molecular mass, is going to give you your number of moles. So this in this case comes out to be 0.5. So the number of molecules will be 0.5 into the Avogadro number to 10 to the power 23, and this gives you 3.011 into 10 to the power 23. And in the P part, it says a group of atoms carrying a charge are called polyatomic ions. Group of atoms, basically like this, as you can see, this is a polyatomic ion. How polyatomic? Because it has a number of atoms, right? If it would have been a single atom, it would be just nitrogen or just oxygen or just sulfur or just chlorine. In case of diatomic, it makes it to be um, let us say an oxide of nitrogen, NO. It may be a CLO. These are diatomic, 2 atoms. And the moment you have 3 atoms, it makes it triatomic, like water. H2O, it's a triatomic molecule. NO2, it's a triatomic molecule. And also then when it comes about SO4, SO4 minus 2. Now, balance is not what we are concerned about right here. We have S, which is connected to 4 oxygens. This is just the general structure. You have uh, double bonds here as well, but we are not going to go into that details right now. We'll just be considering that you have S, which is being bonded to 4 other oxygen atoms, so that makes it a polyatomic ion. And then in this case of methane or CH4, you have a carbon that has been joined to 4 other hydrogen atoms. This is also polyatomic. So any atom, any group of When you have a group of atoms which have been put together and they have a charge, it's called a polyatomic ion. Polyatomic because it has a group of atoms, and ion because it carries a charge like SO4 minus 2. So these are polyatomic molecules. These are the examples of polyatomic molecules, but they are not ions actually because they don't have a charge. So when they get a charge of, let us say, if I remove this hydrogen from here, it will make it a CH4, CH3 plus, CH3 plus, and this is definitely a charged ion. So this is how you make polyatomic molecules to ions. And I hope this concept was pretty much clear to you. The last question of this module says, what are the conditions for work to be done? And uh, then in the B part, you have a numerical that says an electric bulb of 60 watts is lighted for 10 hours a day. What is the amount to be paid in a month for 30 days if 1 unit of electricity costs 3.50 rupees? So in the first case, the conditions, these are very necessarily and this necessarily have to be satisfied for the work to be done is A, the force should act on an object, and then B, that the object must be displaced. All right. So let me give you an example. So if this is my body, this has been kept on this plane. This is a inclined plane, right? This is my plane, and I'm trying to put a force here. So my force, let us say this is F force, F newton of force that has been applied to this body B. So when shall I say that I have done work would be that I'm applying a force. Yes, I'm applying a force, and that this object must be displayed. That means this B should come here after that. If this B has this much amount of displacement S under this force, that means the work is done in this case. Right? If it doesn't get displaced, that is, it doesn't come to this position, that no work has been done because it has no displacement. And you know that force is nothing but work is nothing but force into displacement. So if your displacement is zero, your work done will be zero. So force and displacement are the two necessary conditions which need to be satisfied in order to say that our work has been done. So this was the first part. Now the second part says that a power is given to us to be 60 watts for a bulb like this. It has a power of 60 watts. And then it says the time for this is 10 hours. And then you can easily know that calculation of energy is done by the formula of power P into time T seconds. That makes it 60 into 10. That makes, and this the unit is W hours. That is watt hours. Watt is for the unit of power, and T has its unit as hours. So this comes out to be 600 watt hour or 0.6 kilowatt hours. So the bill that we had to be saying as 3.5, I think rupees 3.5 per unit of electricity. That means this 3.5 per unit into 30 for 30 days calculation into 0.6 of 1 day consumption is going to give you a total of amount of rupees 63. So this is going to be a billing amount for a bulb of power 60 watts that has been used for 10 hours, and when you have a billing rate of 3.5 rupees a unit. So this is how much bill you got to pay for this bulb and its energy consumption. And with this, we come to the end of the module. I hope I was able to deliver the concepts and fundamentals to you in a proper way. And we'll meet in the next module. Till then, keep learning and keep growing and stay safe. Thank you.